Hi everyone, in Algebra 3 today we're going to be going over the new material in lesson 74 as well as going over some of the problems in this lesson as well. The way I would like you to do this problem if you haven't been paying attention is to make sure that I will tell you the problems that I would like you to attempt, and then I want you to attempt those before actually doing them with me so that you will be given the opportunity to actually try before you actually just copy it down. So the idea is for you to actually learn and not just copy these answers down. So we're going to be looking at lesson 74, which is on something called Cramer's rule. Now in Cramer's rule, we are going to be following this pattern here, and we're going to be inputting our variables into a matrix. A matrices in the numerator, and the constants replace the coefficients of x when we solve for x, and the constants replace the coefficients for y when we solve for y. So basically, what we're going to be given is we're going to be given an equation that looks like this, and we're going to plug them into matrices on the top and bottom so that we can solve for x and y. And then you know how to solve for a matrix. Remember, top left times bottom right minus top right times bottom left. Now, the denominators of both of these should look exactly the same. All they are is the coefficient of a and y, and then x and y, and then x and y. So xy of both of the equations, and both of them are the same. So the denominators matrix should look the same. What I like to think of it as is a column of x and then a column for y. Now, if I'm solving for x, the y column is going to stay the same, so it should be BD, BD. But the x column is going to change to what the equation is equal to. So in this case, it's EF. So the bottom, this is your x column, this is your y. If you're solving for x, the numerator's x column changes to what the equation is equal to. The y column stays the same. And then if you're solving for y, the y column is going to change, but the x column stays the same. Notice that it's AC, AC, but then my y column turns to E and F. So I know that's a little bit confusing, so I do want to go through one of the examples in order to help you better understand what we're doing. So for this one, this is my example. I'm going to start with solving for x, and it's going to be a matrix over a matrix. And then for y, it's going to be the same. So it's going to be a matrix over a matrix. Now, I like to think of this as my x column and my y column. My coefficients go here for x, so this would be 3, 4. And for my y column, it will be 2, -3. That's going to be the same for both, so 3, 4, 2, -3. But for my numerator, if I'm solving for the x column, my y column stays the same, so it would be 2, -3. But my x column changes to what the equation is equal to, so -1 and 10. Now when I'm solving for y, the x column stays the same, so 3, 4, and my y column is going to change to -1, 10. Now to solve, I'm going to start in the top left times bottom right, so that would be -1 times -3 minus top right times bottom left, which would be 2 times 10, over top left times bottom right would be 3 times -3, minus top right times bottom left, which would be 2 times 4. So in the top, I'm going to get -1 times -3 would be 3. -2 times 10 would be -20. 3 times -3 is -9, and then -8. So that would leave me with -17 over -17, which means that x is going to be equal to 1. Now that I've solved for x, now I'm going to solve for y. Now I've already solved for the y's denominator because it's all going to simplify to the same thing. So it's still going to be negative 17, but I still need to do the numerator. Start in the top left times bottom right, so 3 times 10 minus top right times bottom left, so negative 1 times 4, and that's all going to be over negative 17. 3 times 10 is 30. 2 negatives make a positive, so positive 1 times 4 would be 4 over negative 17. So 34 over negative 17, which means that my result for y is going to be equal to negative 2. And you do need to solve these by Kramer's rule, so you do need to make sure you know how to input these variables. So that's the example that we're going to do together. Now what I would like you to attempt, I would like you to attempt numbers 8 and 9, as well as numbers 16 through 30. So 8 and 9, and then 16 through 30 before you press unpause and do it with me. So for number 8, I'm going to start with solving for x. So I'm going to have a matrix over a matrix like this. Then y is going to be the same, so a matrix over a matrix. Remember, I have an x and a y column. My denominator is going to be filled with the coefficient for x, so 2 and 4. And then the coefficient for y, which would be negative 3 and 2. That's going to be the same for both. When I'm solving for x, the x column changes to what the equation is equal to, so it'd be negative 4 and 8. Y column stays the same at negative 3 and 2. When I'm solving for y, the x column stays the same. The y column changes to what the equation is equal to, which is negative 4 and 8. Now I'm going to evaluate. So top left times bottom right would be negative 4 times 2 minus top right times bottom left, so negative 3 times 8 over top left times bottom right, so 2 times 2 minus top right times bottom left, so negative 3 times 4. Now negative 4 times 2 is going to be negative 8. Two negatives make a positive, so that's going to be positive 24 over 2 times 2, which is 4. 2 negatives make a positive, and that's going to be plus 12. Now I'm going to evaluate. So I have 24 minus 8, which gives us 16, over 4 plus 12, which is also 16. So I know that x is equal to positive 1. Then for y, I have to do the numerator, so that would be 2 times 8 minus negative 4 times 4 over positive 16, because I've already evaluated it. Then I have 16 plus 16 all over 16. So 32 divided by 16 means that y is going to be equal to 2. Now let's attempt number 8 together. So hopefully you've already attempted it. Now you can check to see if your answer matches my answer. So looking at number 9, I'm going to do it a little smaller this time so I can fit it on this paper. And then y, same thing, matrix over a matrix. So I have my x column, then a y column. So x column is going to be filled with 3 and 1 because the coefficients of x Coefficients of y are 1 and negative 2. Both of them are going to look the same in the denominator. When I'm solving for x, the x column is going to change to what the equation is equal to, so negative 2, negative 3. The y column is going to stay the same. When I'm solving for y, the x column in the numerator stays the same, but the y column is going to change to what the equation is equal to, so negative 2, negative 3. Now we're going to multiply. So negative 2 times negative 2 minus 1 times negative 3 over 3 times negative 2 minus 1 times 1. So now I have negative 2 times negative 2 is 4. Negative 1 times negative 3 is 3. 3 times negative 2 is negative 6, and negative 1 times 1 is negative 1. So I have 7 over negative 7. So I know that x is equal to negative 1. Now for y, top left times bottom right, so 3 times negative 3 minus negative 2 times 1 all over negative 7. So that's going to be negative 9 plus 2 over negative 7. So negative 7 over negative 7 means that y is equal to 1. Okay, so you should have attempted those problems before actually doing them with me, just so that you know that you kind of understand what's going on. Now we're going to do numbers 16 through 30 together. So this one we're just evaluating for our matrix. So it's basically what we did today. We're going to be starting with the top left times bottom right. So that would be, for number 16, we'd have x minus 1 times x minus 5 times 3 equals 5. So if I distribute that, I'm going to get x squared minus x minus 15 minus 5 equals 0. And that would become x squared minus x minus 20 equals 0. And that factors evenly into x minus 5 times x plus 4, meaning that I have two answers for x. I will have x is equal to negative 4, and then x is equal to positive 5. Now for number 17, I have a parabola has its vertex at negative 2, 1, and its focus at negative 2, negative 2. Write the equation of the parabola, the directrix, and the axis of symmetry. So for number 17, what I'm going to start by doing is just graphing it. So negative 2 up 1 is going to be my vertex. My focus is negative 2, negative 2. I know that my vertex or my parabola always opens up towards my focus, so it should look something like this. Now I can solve for the axis of symmetry. I'm going to draw a dotted line through both of those points, and wherever it crosses the x-axis is what my axis of symmetry is going to be. So my axis of symmetry is going to be at x is equal to negative 2. Now my directrix is going to be the same number of spaces between the axis of symmetry and the vertex and the focus. So I'm going to count 1, 2, 3. 1, 2, 3 means that this right here is going to be my directrix. And that crosses the y-axis at 1, 2, 3 at positive 4. Now these are going to be your first two answers. Then my equation of the parabola is going to be as follows. Y equals 1 over 4p times x minus h squared plus k. Now h and k are just going to be the coordinates for the vertex, which they give us at -2, 1. And then p is going to be the distance between the vertex and the focus. And since it's down, it's 1, 2, 3 down. That means it's going to be equal to -3. So I'm going to plug in what I know. I have y equals 1 over 4 times -3. So again, that's the distance between the vertex and the focus. And since it's going down, it would be negative. So it's down 1, 2, 3. The h and the k are just the coordinates of the vertex. So that would be x minus -2 and then plus 1. So -2, 1 is the coordinate of the vertex. Now I'm going to simplify. So my answer is going to be y equals -1/12 x plus 2 squared plus 1. And that should be your result. Now for number 18, we're going to graph the log. And for this one, what you want to do is you're going to convert this from logarithmic form to exponential form. So y equals log 8/3 x. So this is my base. This is my number. This is my exponent. So when rewritten, it's going to be x is equal to 8/3 to the power of y. Now, when I create my x and my y chart, I'm going to plug in -1, 0, and 1. So if I plug in -1 into the exponent, it actually flips this to be 3/8. When I plug in 0, my output will be 1 because anything to the 0 is 1. And then 8/3 to the 1 would just be 8/3. Okay, so now over 3/8 down -1, over 1 up 0, then over 8/3, which would be 2 and 1/3, up 1. And that should be the graph of your logarithm. Now looking at number 19, we are supposed to be graphing the circle. So what I'm going to start by doing is I'm going to put all the x's together, then all the y's together, and then move the 20 to the other side. So this would become, for number 19, I would have x squared plus 10x plus y squared minus 4y equals -20. Now when I take half of this term, it would be x plus 5 squared. And I would add 25, but you have to do that to both sides. Half of -4 is going to give me y minus 2 squared. And then I'd add 4 to both sides, which means that the right side is going to become 29 minus 20 would be 9. So the coordinate for the center of my circle is just opposite of what's given. So instead of +5, it's -5. Instead of -2, it's +2. And the radius is just going to be the square root of the right side. So that's 30. Now draw your diagram. So -5, 1, 2, 3, 4, 5, up 1, 2, so that's about here. That's a coordinate of the center. The radius is 3, so I'm going to go 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 down, then 1, 2, 3 to the left. I'm going to connect those dots. So the radius is 3. And that's number 19. Now moving on, we're going to look at number 20, which we need to write in terms of a sine function. So it's currently not in the equation of sine, but I need to write this in a sine function. I think. So what we're going to do is we're going to look at our function here. And it looks like this. So what we need to start by doing is, for number 20, is we need to solve for a, which is going to be the midpoint between the top and the bottom line. So that would be 14 plus -8 divided by 2. Then for b, we're going to find the amplitude, which is going to be the top, so 14 minus whatever I get for b. And then for c, we're going to do 360 divided by the length of the period. The length of the period, if you look here, is going to start at -80. It's going to circle down, circle through, and then it's going to end at 160. So the distance, the length of the period, would be from -80 to 160. So when I evaluate the length of the period, I'm going to do 360 divided by 80 plus 160. So now I'm going to evaluate. So I have 14 minus 8 divided by 2 gives me 3. My amplitude is top minus whatever I get for a, so top minus 3, so that's 11. 160 plus 80 is 240. So I have 360 divided by 240. And that would be equal to 3/2. Now, I can plug in what I know. So I have y equals 3 plus 11 sine 3/2. And now this is the phase shift. So currently it's sloping up through 40 degrees. We want it to slope up at 0 degrees. So we need to shift this whole graph to the negative direction, -40. So it's currently sloping up at +40. We want it to slope up at 0. So we're going to do -40. So we have x minus 40. Okay. So now moving on to number 21. So for number 21, it's kind of a similar problem. It says write the equation of the sinusoid whose graph is a sine function with a center line of -1, an amplitude of 14, a period of 360, and a phase angle of -40. So that they give us everything we need for number 21. We have A, which is the midline, the center line, which is -1. We have B, which is our amplitude, which is 14. C, they give us the length of the period. So we would do 360 divided by the length of the period, which means that's going to be just equal to 1. And now I just need to plug this all into my equation. I have y is equal to -1 plus 14 sine 1, and that's going to be theta minus negative 45. And all we have to do is adjust the fact that we have negative 45. So my answer is going to be y is equal to negative 1 plus 14 sine theta plus 45. So it's always theta or x minus your phase angle. So because it was negative, I had to make it plus. Now I have number 22. So this one, what I'm going to do is I'm going to start by multiplying the outside numbers and then adding the two radians together, and then I'll expand. So 4 times 6 is going to give me 24. And I'm going to have CIS. 6 pi minus pi would be equal to 5 pi over 3. Now when you expand, you can do cosine of 5 pi over 3 plus I sine of 5 pi over 3. Now my snowflake would look like this. 1, 2, 3, 1, 2, 3. Starting at 0, I'm going to count 5. So that would be 1, 2, 3, 4, 5. That is a 60-degree angle in quadrant 4. Adjacents 1. Opposite negative root 3. Hypotenuse 2. Now the cosine of this triangle is going to be adjacent over hypotenuse. So that's going to be 1 over 2. The sine of this triangle is going to be opposite over hypotenuse, which would be negative root 3 over 2. And don't forget your I. And lastly, you just need to distribute your 24. So it's going to be 12 minus 12 root 3 I. Now looking at number 23A, the first thing that I'm going to do is, because the whole number is positive, that means it's going to the right of the origin. Because the I is negative, it's going to go down. So that means we're going to end up in quadrant 4. So this would be 2, 3, hypotenuse, angle. Start by solving for the hypotenuse using Pythagorean theorem. So 2 squared plus 3 squared. So 4 plus 9. H is going to be equal to the square root of 13. Now to solve for the angle, I'm going to use inverse tangent of opposite over adjacent, so 3 over 2. Now you're going to go 3 divided by 2 equals, then second tangent, and that would give you 56.31. But we do need to subtract that from 360 because it's in quadrant 4. So my answer is going to be square root of 13 CIS 303.69 degrees. Now remember, CIS just stands for cosine plus I sine. So when we're asked to write this in rectangular form, that means that they're asking us to expand it. So B would be 13 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. Now over 6, so I have 1, 2, 3, 4, 6. Starting counting at 0, that would be 1, 2, 3, 4, 5. It's a 30-degree angle in quadrant 2, so negative root 3, 1, and 2. Now the cosine of this triangle is going to be negative root 3 over 2. And the sine of this triangle is going to be 1 over 2i. So when I distribute, it's going to be negative 13 root 3 over 2 plus 13 over 2i. Now moving on to number 24, where our answer does need to be in radians. We are going to start by moving the 3 to the other side. So that would be 24 would be 4 cosine squared t equals 3. Divide both sides by 4. And now take the square root of both sides. So I'm going to get cosine t is equal to plus or minus the square root of 3 over 2. Now that's going to separate into two equations. So it would have cosine t equals positive root 3 over 2, and then cosine t equals negative root 3 over 2. So now what I'm going to do is I have to find out where cosine is positive. So all students take calculus. Everything's positive in quadrant 1, and cosine is positive in quadrant 4. So that's going to be positive root 3 over 2, meaning that that angle is going to be a 30-degree angle. Now for the negative one, it's going to look the same, but instead of in quadrant 1 and 4, it's going to be in quadrant 2 and 3. So that would be negative root 3, 2. Same angle. So now what I'm going to do is I'm going to draw my snowflake chart for that. For 30-degree angles, that means there's going to be a 6 in the denominator. And it's always going to be the line closest to the x-axis. So starting at 0, quadrant 1, the first one's going to be t is equal to pi over 6. For the one in quadrant 2, I'm going to count 1, 2, 3, 4. That will be 5 pi over 6. For the one in quadrant 3, it's going to be 5, 6, 7. So 7 pi over 6. And then 8, 9, 10, and 11. So 11 pi over 6. And those would be your 4 answers for all 4 triangles in the 4 different quadrants. Now looking at number 25. I'm going to start by moving the 1 to the other side. So 2 cosine 2 theta equals negative 1. Divide both sides by 2. So now I'm looking for where cosine is negative. So on my chart, all students take calculus. I know it's positive in 1 and 4, which means that's going to be negative in 2 and 3. Adjacent is going to be negative 1, hypotenuse is 2. So now what I'm going to do is I'm going to draw my snowflake chart for my 60-degree angle. So that'll be 1, 2, 3, 1, 2, 3. So starting at 0, we're going to count 1, 2. So my first answer will be 2 theta is equal to 2 pi over 3. My second answer is going to be 2 theta is equal to 2, 3, 4 pi over 3. Now to get the theta by itself, I'm going to multiply both sides by 1/2. So that's going to be, my first answer is going to be pi over 3. My second answer is going to be 2 pi over 3. Remember, I need 2 answers for each quadrant. So I'm going to set 2 theta equal to 2 pi, which means that theta is going to be equal to pi. So this is what I'm going to add to each of these answers to get my other 2 answers. So if I add just pi to pi over 3, that will give me 4 pi over 3. And if I add pi to 2 pi over 3, that's going to be 5 pi over 3. And there would be your 2 answers for each quadrant, 4 answers total. Now looking at number 26. So number 26 is going to be a very long problem. So what I need to do is I'm going to start by moving the square root to the other side. So I have secant x is equal to the square root of 2 secant x minus 1. I'm going to square both sides. So I get secant squared x equals 2 secant x minus 1. Now I'm going to set this equal to 0, so I have secant squared x minus 2 secant x plus 1 equals 0. Now on the side, I'm just going to set secant x equal to z, so that I have z squared minus 2z plus 1 equals 0. So if I factor that, it factors evenly into z minus 1 squared equals 0. So now, so when I solve for z, I would set z minus 1 equal to 0. So z would be equal to 1. Now if z is equal to 1, that means secant x is equal to 1. Now the only way for that to happen would be for us to use the unit circle. So 0, I have 1, 0, 0, 1, negative 1, 0, 0, negative 1. And I am looking for, so secant is the inverse of cosine, so that's going to be 1 over x. So I'm looking for where my x coordinate is equal to 1. So if I underline all my x coordinates, the only place where x is equal to 1 would be at 0. So that means that x is equal to 0. But I do need to check my answer because my original problem had a secant in it, or it had a square root in it. Sorry, that was confusing. So I'm going to do 1 over cosine of 0, see if that's equal to the square root of 2 times 1 over cosine of 0 minus 1. So cosine of 0 is going to be equal to 1. So 1 divided by, 1 divided by the cosine of 0 equals 1. So if 1 divided by the cosine of 0 is 1, that would be the square root of 2 times 1 minus 1, which would be the square root of 1. And 1 does equal 1, so therefore my answer is x is equal to 0. So it's not 0 degrees, it's 0 radians, because remember our answer has to be in radians. Now looking at number 27, we have cosecant squared negative 3 pi over 4 minus cotangent squared of negative 3 pi over 4 plus secant squared of negative 3 pi over 4 minus tangent squared of negative 3 pi over 4. So for number 27, I'm going to draw my snowflake for over 4. So that's 1, 2, 3, 4. 1, 2. And if I start counting in quadrant 4, I'm going to go 1, 2, 3. That's going to be a 45-degree triangle in quadrant 3. So that's going to be -1, -1 root 2. Now, cosecant is the inverse of sine. So that's hypotenuse over opposite. So that's a negative root 2 squared minus cotangent squared. So cotangent is the inverse of tangent. So that's adjacent over opposite. Just be 1. Secant is the inverse of cosine. So hypotenuse over adjacent will be negative root 2 squared minus the tangent, which is opposite over adjacent. That's 1 squared. Negative root 2 squared is just going to be 2 minus 1 plus 2 minus 1. So 4 minus 2 is equal to 2. Now moving on to number 28. So what we're going to do for number 28 is if you see a number outside your log, it becomes the exponent. So this is going to be for number 28. We're going to have ln of 16 to the 1/4 plus ln of x squared equals ln of 6 minus x. Because of this plus sign, I'm going to combine, and 16 to the power of 1/4 is equal to 2. So this is going to turn into ln of 2x squared is equal to ln of 6 minus x. Now to get rid of the ln, I'm going to raise both sides to the power of e and set this equal to 0. So this is be 2x squared plus x minus 6 equals 0. Let's do quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So I have negative 1/4 plus or minus. Okay, so 4 times 2 times 6 gives us 48. Plus 1 would be the square root of 49, so that would be 7/4. So -1 plus 7 would be 6/4, so that would be 3/2. Then -1 minus 7 would be -8/4, so -2. Remember though, we can never take the log of a negative number. So if I plug in this -2 into here, that would be the ln of -2. You cannot do that. So therefore your only answer is going to be 3/2. Now moving on to number 29, I have b to the power of, I see the minus sign, so I'm going to combine those. So that would be log b of 24 divided by 6, then plus log b of 3 squared, because there's a 2 outside the log. Then I'm going to have b to the log b of 4 times 9. And the b and the log b are going to cancel, so my result is going to be 36. Now for number 29, part b. There's a number outside my log, so I'm going to raise that to the power. So it would be ln e to the second minus log 10 squared to the power of 2. So that really turns into ln e to the second minus log of 10 to the 4th. Now the L and the E actually cancel each other out, and the log and the 10 cancel out, so that's actually 2 minus 4. So the result is actually negative 2. Now lastly for C, I again have a number outside my log, so it's going to be ln e to the 4th to the power of 2 plus ln e to the 1/2 to the power of 4 minus log 10 to the 5th. So this is going to turn into ln e to the 8th plus ln e to the 2 minus log 10 to the 5th. So I just said the L and the E actually cancel, and the log and the 10 cancel. So I really have 8 plus 2 minus 5 equals 5. And then lastly, number 30. We have x squared plus 20. We have to factor over the set of complex numbers. We can do that by either doing quadratic formula, or we could complete the square. So that would be A would be 1, B would be 0, C would be 20. So that would be x equals, the heck? X equals negative 0 plus or minus the square root, 0 squared minus 4 times A times C all over 2 times A. So that's just going to turn into plus or minus the square root of 80i over 2. The square root of 80 would be 4 root 5. Over 2, which means it's going to be plus or minus 2 root 5. So my result is just going to be x minus 2 root 5, I, don't forget the I forgot the I, and then x plus 2 root 5i. And hopefully you've done all those problems at least once and then check them over with me so that you were able to get started on your lesson 74. And I hope you guys all have a great day. Bye.